Greetings to all. In today's session, we are going to discuss about intermediate level chemistry on international platform for competitive exams or any entrance examinations, India level JEE Advanced and JEE Mains, NEET examination for medical entrance, so which is most valuable for the entrance examinations, and also Telangana EAMCET, Andhra Pradesh EAMCET examinations, the people who are aspiring for any competitive exam. For all these, this content will be very much helpful. The chemistry topics whichever covered over here collected from the reputed platforms from the Google, and the previous year question papers are mentioned over here in the detailed manner, so that it will be very much helpful for your content retrieval. Let's enter into our first question. Question number 1. Among the following, maximum covalent character is shown by the compound. These are the compounds provided among all. We have to depict which is having highest covalent nature, highest covalent character. One is magnesium chloride, iron chloride, tin chloride, and aluminum trichloride are provided. Right, in accordance with the Fazans, there will be a certain regulations in order to measure the covalent nature of the given compound. Right, so here among all, which will have the highest covalent nature can be regulated by few rules and regulations. Here the ionic nature is given by low positive charge. If the compound is covalent, high positive charge is required. In this regard, if you compare all the compounds, magnesium chloride is having magnesium +2 and the Cl-, iron +2 will be there, tin also +2, where aluminum is having +3 oxidation state around the central aluminum. If you go with the second one, large cation and the small cation. Large cation will accord the ionic nature. Smaller the cation will accord the covalent nature. Right. So in this regard, we have to compare the ionic radius of all these ions. Right. And next is about small anion or large anion. Small anion if present, we can go for ionic nature. Larger the anion, we have to confirm that the compound is covalent in nature in this regard. So here, if you observe all the compounds here, all are having the negatively charged ion is a chloride only, so that it is not applicable. Chloride it remains a constant. So this last point is not applicable for the given compounds. We have to go for the remaining two. One is high positive charge, second is small cation. So if you observe these two possibilities, so that we can confirm which is having maximum covalent character among all the four compounds which are provided over here. Let's go with the one by one description. If you see this entire periodic table, in this magnesium metal is having 1.41, whereas magnesium dipositive ion, that means a magnesium cation, is having radius size of 0.86. Aluminium is having 0.68, right? So aluminium +3 is having 0.68 compared to 86. is lesser only. If you compare remaining two cations also, one is iron +2. When ferrous was taken, its charge is taken as 0.74. 0.74 is next to 0.86, right? So tin +4 is 0.83. So if tin +4 is 0.83, if you go for tin +2, still the size will increase, because larger the positive charge, shrinking in the size is more. If tin +4 is 0.83, tin +2 will have greater than 0.83, so that it will be the largest among all the given options. Tin +2 will be the largest. Next followed by magnesium +2, next followed by iron +2, 0.74, and the least size accorded for the aluminium +3, that is 0.68. Greater the positive charge, shrinking in the size is more, smaller will be the size, right? So in this manner, small the size, more covalent character as per the table what we discussed. Small the cation size, greater will be the covalent nature. So in this regard, aluminium is having smaller ionic radius. Here ionic radius matters. Whenever it is in ionic state around the central metal, then only we can go for its covalent nature, right? Smaller the size, more covalent. In this regard, aluminium +3 is having smallest radius. Go with the charge. Magnesium chloride is having +2. Iron chloride is having +2. tin chloride is having +2 oxidation state on the central metal, whereas aluminium trichloride is having aluminium +3. So that we can say aluminium trichloride +3, more the charge, more will be the covalent character. In both the cases, aluminium trichloride will be the right option for maximum covalent nature. For question number 1, option number 4 will be the correct explanation. Let's go with the question number 2. Question number 2, which of the following substances used in the black and white photography? Okay, so in the photography fixation, there are certain compounds will be used. One will be hypo and another will be silver bromide, right? So in photography, the compound used is called silver bromide. Artificial raining, we will use a silver iodide. Here photography, we will use a silver bromide. Let's see how can we explain this one, right? Silver bromide is used in black and white photography. Photographic film is coated with the silver bromide. The light, when captured on the surface of this silver bromide, as the part of the film is darkened, some of the part of the film will be darkened and photograph will be developed. Okay, so here that's the reason why we can use silver bromide. Silver bromide having tendency to capture the light whichever coming from the source, and the darkening of that light is possible in the presence of silver bromide, so the development of film is possible, right? When we capture the picture, camera lens project the small but accurate image, right? Lenses are used to capture the images. Accurate images got captured over there, right? So there will be a coating of light sensitive layer, right? So in the presence of light sensitive layer, silver bromide will decompose. Whenever silver bromide is decomposed, so depending upon the intensity of light, so how extent silver bromide decomposed will depends upon the light intensity whatever we are projecting there, right? So that image clarity will depends upon the extent of decomposition of silver bromide and the intensity of light as well, right? Silver bromide soft and pale yellow color in nature, water insoluble substance, and sensitivity of it is having sensitivity towards light. That's the reason why whenever light captured by the photograph, so that silver bromide will participate in the decomposition, so that the development of film is possible. This is the way we will use silver bromide in the development of photography, right? Let's move on to any other components whichever provided in the options. Sodium chloride is used as a table salt in general. So table salt, that is the very essential component of food diet, and which used to preserve the foods as well. If you go with the pickles or any other, we can conveniently store for a longer time due to the presence of silver chloride only. As a preservative, salt helps to prevent the spoilage. Food spoiling can be completely avoided due to the presence of sodium chloride, which used to maintain the concentration, so that whatever pathogenic or decomposing microorganism can't attack on that food material whatever we are preserving for. Salt is also used to fermenting process. In the fermentation process also we can use salt. Fermentation simply called in the presence of enzymatic action. Complex organic compound will be converted into simpler molecules is called a fermentation, right? Sugarcane, sugar cane, pickles, and kaffir, all these materials got fermented in the presence of salt. These many applications you can find for table salt called sodium chloride. Let's go with the calcium nitrate. Calcium nitrate is the very important source for the nitrogen fertilizer. It is used to release nitrates directly to the plant materials, which is very essential. As we are aware, in the agricultural field, N, P, K are the requirements. N for nitrogen, P for potassium, P for phosphorus, K for potassium. These are the chemicals are very essential for the growth of plants, and these are called macronutrients. Macronutrients means which are required in the maximum quantity, right? Nitrogen containing fertilizers. So this will be the nitrate. Nitrate is the compound or form of nitrogen which can be directly absorbed by the plant material. Molecular nitrogen or elemental nitrogen is not suitable for the absorption by the plants. Rather, the suitable form to absorb the plant materials are nitrates only. So that we can see calcium nitrate is the suitable material as a fertilizer in the agricultural field, which directly impact the production of crop yield. right? This is the very important application, we can say. And moreover, in the wastewater preconditioning process, so wastewater called sewage water, any industrial effluent, any kind of material whichever excreted can be used to eject odor. So many foul odor containing materials will be emitted whenever calcium nitrate is added, so that it used to prevent that kind of unpleasant smell, right? And insert accelerating concrete admixtures in the concrete, means in the construction purpose for the building construction or road construction, this calcium nitrate is also one of the ingredient used, being calcium is the strengthening agent. And another option given is called calcium hydroxide. The calcium hydroxide very well used in the sewage treatment. Sewage is the wastewater coming from the household process or else industrial effluents, so whatever the kind it might be, calcium hydroxide is used in the sewage treatment process. And moreover, paper production, the manufacturing of paper from the pulp of the plants, here calcium hydroxide can be used. Constructional purpose and food processing, we can use calcium hydroxide. So medical and dental uses, calcium hydroxide used in the any dental treatment process, and the medicinal applications also given for this calcium hydroxide. Calcium hydroxide is called lime and used in the whitewash of the buildings, we can see. Root canal treatment, root canal treatment is nothing but whenever the person suffering from the teeth cavity, in that case root canal is required, so that from the roots of the gums we will clean any kind of rotting material, any decomposed material if present. Root canal treatment used to clean up that kind of cavities whichever present from the root level, right? And in that treatment also, in the cleansing process also, we can use this calcium hydroxide. So this is the way we can go for question number 2. Right answer will be silver bromide. In photography, the probable chemical applied is silver bromide. Let's go with the question number 3. If the primary valency of the central metal ion complex cobalt NH3 taken 6ClCl2 is N, its secondary valency is Y, then find the value of X and Y. Okay, here this is the question given from the complex or coordination chemistry, right? Coordination complex sphere, it is wherever any compound represented in the square bracket is called a complex. Outer the sphere, whatever ions are present, those are called ions, right? These are ionizable substances. Ionizable substances will impart a primary valency, and the complex substances will impart the secondary valency. Here, primary valency and secondary valency sum we have to depict. The answer could be 9. Let's see how can we predict this. Answer 9. If you see this, the compound is given as the central cobalt surrounded with the set of 6 ligands within this coordination sphere and occupying octahedral geometry in this manner. And among the 6 ligands, 5 ligands are purely neutral in nature. Chloroligand is having dual nature, acting like a primary as well as secondary valency. Being it is a charged species, it also accords the oxidation state to the central cobalt metal, and also impart the coordination sphere, so that primary and secondary both the valencies got satisfied by this internal chlorine, and the remaining 2 chlorines whichever present in the outer sphere are the primary valency, right? So in this manner we can say secondary valency of the complex whichever surrounding the central metal, the set of ligands are called the secondary valency. Let's count 1, 2, 3, 4, 5, 6. There are 6 ligands around the central cobalt. Set of ligands are 6. So that 6 is the secondary valency. And if you count its ionic components which impart the oxidation state to the central metal are outer 2 chlorides are there, inner 1 chlorine is there. Total number of a total number of charged species are 3. So that primary valence is accorded by the 3 ligands, 3 chlorines. One is inner sphere. Another 2 ligands, another 2 chlorides are out of the sphere are there. So that 3 are the primary valency. 3 plus 6 total 9, right? 9 will be the sum of primary and secondary valency. For question number 3, 9 will be the right answer. Let's move on to question number 4, where this is the question given from analytical chemistry, and where you're operating the solutions in the laboratory, volumetric titrations like that. This kind of question will be very much helpful. Analytical part it will be. 5 grams of sodium hydroxide dissolved in water, and the solution, resulting solution is 450 ml. What volume of solution is required to prepare 500 ml of 0.1 molar sodium hydroxide solution? Here, 5 grams of sodium hydroxide, 450 ml of water will be prepared. We have to get its molarity. After getting molarity, we have to go for another formula. M1V1 is equal to M2V2. If one of the molarity is known, it is obvious to get the molarity of unknown solution. So one of the molarity is 0.1, and this molarity is also known, and required volume is 500 ml. What volume of this stock solution we have to take, that part we will take over here. In order to get that, we have to go for the stepwise solution for this problem. First of all, we have to solve the molarity of sodium hydroxide. The formula for the molarity is weight by gram molecular weight of sodium hydroxide multiplied with 1000 by volume in ml. Weight by gram molecular weight into 1000 by V in ml is the formula of molarity. Weight is accorded with the 5 grams of sodium hydroxide. Sodium hydroxide gram molecular weight is given as 40,000, and it is prepared up to 450 ml solution. So that 5 by 40,000 by 50. If you go with this molarity calculation, the answer will be 5 by 18 molar. 5 by 18 is solved as a 0.27 molar solution, right? Step 1 got completed. Molarity of sodium hydroxide, whatever prepared, is a 0.27. Let's go with the step number 2. A VML of solution is required to prepare 500 ml of 0.1 molar NaOH. So that here is the formula we have. Required 500 ml of 0.1 molar solution is needed to be prepared. In order to get this solution, the formula is M1V1 is equal to M2V2. M1 means what molarity of solution sodium hydroxide we prepared, that is 0.27. 0.27 is the M1, and V1, how much volume taken is required to be calculated. This is the question. And M2 is the molarity of solution to be prepared, that is 0.1 molar. And how much we have to prepare? 500 ml we have to prepare, right? So that V1 is equal to M2 V2 by M1. M2 is 0.1 molar, V2 is the 500 ml, and M1 is 0.27. So that volume of sodium hydroxide required will be 180 ml. So this is the way we have to go for the solution. 180 ml is the correct answer. For question number 4, 180 ml is the right answer. Let's go with the question number 5. This is the question collected from the organic chemistry previous question paper, and here you can find the cyclic hexagonal ring, cyclohexane, which is having ester. So here COOMe is called ester, and this is called methyl, and here you can find double bond, and here you have a side chain of CH2 CH2 CHO. Within the compound, there are 3 unsaturated functional groups. One is aldehyde, another is alkene, another is ester. 3 unsaturated compounds are there. Here is the reagent added called sodium borohydride. Okay, sodium borohydride is the selective reducing agent and mild reducing agent. That part we have to remember. So based on the reagent added, the selective reduction will followed. In the presence of sodium borohydride, which kind of unsaturation can be reduced, that we have to predict, right? So here so many options are given. In the option number 1, all 3 unsaturated all three unsaturated fragments got reduced over here. And in the second one, only ester and aldehyde got reduced unaffected with the double bond. In the third one, unaffected with the ester, double bond and aldehyde got reduced. In the option number 4, only aldehyde got reduced, unaffecting double bond and ester. Okay, as we already aware, sodium borohydride is called a mild reducing agent. It is very selective for the reduction of aldehydes, unaffecting double bond and ester. So that we can say option number 4 will be the correct answer for question number 5. Let's see how it can be. Whenever ketone is there, the suitable reducing agent will be lithium aluminum hydride. Whenever aldehyde is there, we can apt sodium borohydride. Selective for the reduction of aldehydes and unaffecting ketone and double bond. Here, ester and double bond got unaffected. Only aldehyde group in the central compound will be reduced in the presence of sodium borohydride. Right? So for question number 5, option number 4 will be the correct answer. Let's move on to the last question of the session. Again, it is the part of organic chemistry and the question is based on IUPAC nomenclature. In accordance with the International Union for Pure and Applied Chemistry, what is the IUPAC name of the below given compound? This is a compound where we are having benzene ring, nitrogen having one methyl, one ethyl. This is a compound of amine and moreover we can say tertiary amine.Amine's general IUPAC name is given as alkanamine. Right? Here so many names are provided. Among them, we have to depict which will be the right answer. Among all, the correct answer will be N-ethyl benzanamine. This will be the correct name. N-ethyl benzanamine is the correct IUPAC name of the given compound. Let's see how can we accord this nomenclature for the compound. Amines, general IUPAC nomenclature is given as alkanamine. Amines are called alkanamines. If you are having one carbon, methanamine, two carbons, ethanamine, benzene, benzanamine. So that if aniline is there, means a benzene containing NH2, we can say it is the benzanamine as per the IUPAC naming, right? So benzanamine is the parent ring over here. And here amine is having two alkyl groups over there. Central nitrogen is having two alkyl groups. One is ethyl, another is methyl. Among ethyl and methyl, the compatibility will be alphabetical order. E will come first rather than M. So that alphabetical order will be followed. So that we have to pronounce ethyl first, later methyl, according to the alphabetical order. Hence, the correct answer will be, and this ethyl is there on the nitrogen, hence N-ethyl, followed by another methyl is there upon nitrogen, hence we can say N-methyl, and the parent chain is benzanamine, right? So for this compound, N-ethyl benzanamine is the IUPAC name of the compound. N-methyl benzanamine, right? So by this we completed the session. I'm requesting you to like the channel, whatever we are preparing every day, and if you comment for which topic you are really mostly interested for, and where you found the important thing which will helpful for your preparation, so based on that you can comment over there so that I can find in what way we have to move forward, and share the channel with the people whoever aspiring for the preparation in this regard, and subscribe the channel in order to get the more updates and more such a kind of content for you. Thank you very much for your patient listening. Thank you one and all.